Hello class, today we're going to be looking at graphing linear functions. This is chapter 9, section 3. Just a couple of reminders, make sure that you pause the video, listen to any vocab or examples, write these in your foldable, listen carefully to all of the explanations, and if you have any questions, please see your teacher. This first slide is some of the review vocabulary that we talked about in the previous lesson. A function, domain, range, and function table. These vocab words are going to be used again, emphasizing the graphing portion of what it is to be a function. This is just a slide, it's also in your book, describing what a linear function is. It's a function in which each of the dots on the graph form a straight line. So this is called a linear function. If you have an equation, it's called a linear equation when all of the dots line up to form a straight line. Ways that we can represent functions. You can represent it using words, like given here where you're describing the function. An equation, this equation is y equals x minus 1. You could represent functions by using ordered pairs. We'll look at some ordered pairs in the examples today. You can look at a table of values. Notice the ordered pairs here match up with the table of values. So like we have 0, -1, and that's one of our values in the table as well. 0 for the x, -1 for the y. And then also you can look at this graphically. You can look at functions on a graph to see how they're represented. So this is how you can see how all of these functions are related. This is all representing the same function, y equals x minus 1, just showing it in 5 different forms. This first example, we will have 2 examples for your foldable. This first example gives you a function, y equals -3x plus 1, and then I've already set up a function table, and then we're going to put these ordered pairs that we get from the function table onto the graph. So that's how we would graph, is we pick some random domain values. In this case, we're just going to use a little bit of positive, a little bit of negative. So the values we're going to use today are going to be -2, 0, 1, and 3. So kind of a variety. Definitely put 0 in for the domain, and I'll talk about that point in just a second. So in our first one, we've got -3 times -2 plus 1. And that results in 7. So we have the ordered pair, -2, 7. The next ordered pair is -3 times 0 plus 1. That's 0 plus 1, which is 1. Ordered pair 0, 1. The second graph, or the third one, I'm sorry, -3 times 1. So that's -3 plus 1 is -2. And that gives us the ordered pair 1, comma, -2. And the last one here, -3 times 3 plus 1 is -9 plus 1, which is -8, giving us the ordered pair 3, -8. And now we're going to go over here to the graph. We're going to put these ordered pairs onto the graph. I've already numbered the graph by ones. You don't always have to number by ones, as long as all of the x-axis is numbered by the same increments, and same with the y-axis, as long as all of the y-axis is numbered consistently. So for the first point, we go -2, 7. So I go to the left 2 and up 7, and I put the ordered pair, I put the dot. 0, 1 is right here, and it's on the y-axis. We have a special name for this point. It's called the y-intercept. It's where the line crosses the y-axis. It's called a y-intercept. Okay? The next one is 1, -2, so I go over 1, down 2. And the third point is at +3, so I go over to the right 3 and down 8. So my ordered pair is way down here. And then since this is just a regular graph, I'm going to connect all of the dots to show that it's a straight line. And we can just put a little arrow markers to show that that's a straight line. So this is an example of a linear function. And this equation is a linear equation because it forms a straight line. And here's our example number 2. Pause the video, copy this down, and then we will look at graphing this function and we'll talk about how to solve this kind of a problem. So a store sells t-shirts, which we're going to represent with the variable x, that's going to be our domain, in packs of 5, so they sell 5 t-shirts at a time. And the long-sleeved shirts are going to be y, and those are sold individually. So those we're just going to do that times 1 on. Graph this function 5x plus y equals 10 to determine the number of each type you can have if you buy 10 shirts. So the 10 shirts is represented by this 10. The 1y is representing the long sleeve shirts that are sold individually. And the 5 times x is representing those t-shirts that are sold in packs of 5s. So if you buy 1 pack, that means you get 5 t-shirts, 5 times 1. If you buy 2 packs or 2 x's, that would be like 10 t-shirts because you would do 2 times the 5. So they're giving us what this function looks like ahead of time, what this equation is to use, and now we just need to put this into a function table. Okay, so first we need to take this equation and isolate the y value. That way we've got our function that we can put into our function table. So I just wrote the 5x plus y equals 10. We need to subtract a 5x from both sides. The reason we do this is now we have y equals negative 5x plus 10. So here's our function, negative 5x plus 10, that we're going to put into the function rule as part of the function table. Okay, so we've got our x's, those are our domains. We have our negative 5x plus 10, that's our function rule. We have our y values, and then over here we have, of course, our ordered pair, x comma y. Okay, and we're going to put this just together in a function table. So now we'll start looking at those ordered pairs. So we're talking about t-shirts here and long sleeve shirts. So you can't buy negative t-shirts. So we're not going to have any negative values in our function table. So I'm going to start with the lowest number of t-shirts or the lowest number of packs of t-shirts that you could buy. 0 would be the smallest amount. So we're going to put that value in, negative 5 times 0 plus 10. So that's 0 plus 10 is 10. So if you buy 0 packs of t-shirts, that means you could buy 10 long sleeve shirts. Okay? Let's go with the next whole number because you can't buy part of a pack. You have to buy the whole pack or nothing. So if I buy 1 pack of t-shirts, that's negative 5 times 1 plus 10. So that's negative 5 plus 10. That means I would have enough money left over, or in the equation, if I buy 1, or if you buy 1 5-pack of t-shirts, you could buy 5 individual long sleeve shirts. Okay? And what if we buy 2 packs? Negative 5 times 2. So we have negative 10 plus a positive 10 means you can't buy any long sleeve t-shirts now, because if you buy 2 5-packs, that would be your 10 shirts that you bought, and it said if you're only buying 10 shirts. So that means we could buy 0 long sleeve shirts. And we can stop right there, because if we keep going with this domain, these values here for the y's are going to be negatives. And like we said, you can't buy negative t-shirts. So now I'm going to go over here to the graph and enter this data that we just found. I'm going to enter those data points onto the graph. So if I buy 0 t-shirts and 10 long sleeve shirts, that's right up here on that y-axis. There we have that y-intercept that we talked about before. The y-intercept. Okay. 1 and 5, so I go over to 1 pack of t-shirts. 5, it's not on my grid, but I can just put a dot in between the 4 and the 6 because that's where the 5 would go. And 2, 0 would go right down here. And that one is called the x-intercept because that's where it crosses the x-axis. I'm not going to connect these dots. The reason I'm not connecting the dots is because if you go in between the 1 and the 2, if I draw this line here, that would imply that I could buy 1.5 t-shirts. There would be an ordered pair right there. Well, I can't buy 1.5 packs of t-shirts. Or, I can't buy half a t-shirt or 0.1. I can't buy the in-between parts. These numbers have to be integers, and there's one of our number sets. They have to be integers because you can't buy part of a t-shirt or part of a pack. So they have to be left as just the dots. We can't connect the dots because you can't buy part of a t-shirt. Okay, so we don't have any of these ordered pairs in between here. They're non-existent. So that's why we don't connect the dots, because these points in between do not exist. Okay, so this is looking at graphing functions, setting up the table of values. Okay, we looked at ordered pairs, and then we also looked at a couple key points like the y-intercept, and here is the x-intercept. Okay, so have fun, good luck, ask your teacher if you need some clarification. Thank you.